Yeah, so we solve number 18. So let's start with the 19. Yep, this one is difficult. Let me see. So in this problem, we want to multiply all the elements within the interval. So let's just start with the number 1 when j is 1. Yep. K should be greater than j, so k should be 2. And then we can increase the value of k up to when k is n. And then we can increase the value of j to number 2. So when j is 2, k starts from 3 because k should be greater than j. And then we can continue to increase the value of k up to n. So if we keep this trend, I mean the last product will be j is n minus 1 and k is n. That will make the last term. And we can make the sigma notation to find this sum. So the j is the first number in the product. So j starts from 1 and it ends with n minus 1. So that means if we use the sigma notation, j is 1 to n minus 1. And for k, we need another sigma notation. And k is always greater than j, so k starts from j plus 1. And then k will end with the n, and that makes k's sigma notation. So to solve this sigma notation, we need to use some formula. For the second sigma notation, to start from j plus 1, we need to subtract k is from 1 to j. So after making this subtraction, now we are starting from the j plus 1. So for the first sigma notation, it's like adding 1 to 1 through n. So the sum is n times n plus 1 divided by 2. And for the second sigma notation, to find the sum of 1 through j, yep, so let me say this way. This means we are adding 1 through n, right? This sigma notation means. And the sum of this is n times n plus 1 divided by 2. Yep, so that's why I can change the first sigma notation to n times n plus 1 divided by 2, and for the second sigma notation I just change n to j. And then we can open the parenthesis, and in this case the n times n plus 1 divided by 2 can come out of the sigma notation, because this sigma is made for j, not n. Yep, that's the opening of the parenthesis. And for this sigma notation, because it's added to n minus 1 instead of n, the formula slightly changes. So if we add 1 through n minus 1, the sum will be n times n minus 1 instead of n plus 1. And there is also formula to find the sum of the cube and squared, like this. If we add 1 cube through n cube, the sum is this. And if we add 1 squared through n squared, the formula is this. So I'm going to change this to j, and then once again the nth term is n minus 1 instead of n, so I'm going to put n minus 1 in place of n in this formula. So that means the sum of the cube is and sum of the squares and after opening parenthesis we can simplify this expression. This one is really hard. Yep. So at first, the common factor is n times n minus 1. Yep, and then let's simplify the big parentheses. Yeah. Oh, I think we can take 24 out for the denominator. And now let's open the parentheses. Yep, can you factor this 3n squared plus 5 and time plus 2? You're right, and n plus 1, right? Like this. Oh. Yep, so this is the expression for s, the sum. And then when we go back to the question, oh, we want to find the value of n which makes s divisible by 3. So this expression should be a multiple of 3, but it already contains 24. So that means the these four product, the product of these four numbers will be the multiple of 72, because 24 times 3 is 72, and multiple of 72 means it should be a multiple of 8 and multiple of 9. 8 times 9 is 72. So let's first check if this is a multiple of 8. So in this case, the neighboring numbers are multiplied. N is adjacent to n minus 1 and n plus 1. That means if n is odd, n minus 1 or n plus 1 should be even. Or if n is even, n minus 1 or n plus 1 should be odd. So what I want to say is at least one even number is already contained in this product. So to check a multiple of 8, because it's already a multiple of 2, we only need to check if this is a multiple of 4. So I'm going to think of 4 cases when n is divided by 4. So the first case is, let's say n is a multiple of 4, so that means n is 4k. In such case, the expression for this product is like this. So it contains a number of multiple of 4, and this one is even. So 4 times 2 is 8. So in this case, this product is a multiple of 8. That's the first case. or let's say n is 4k plus 1. And now the second term is 4k. And so in this case too, it has the factor of 4 and this is even. We can take 2 out of the parentheses. So in this case too, the product is multiple of 8. So if we change n to 4k plus 2, in this case, the first number is even, and the last number is a multiple of 4. Or we can take number 4 out of the parentheses. So 2 times 4 is once again multiple of 8. So finally, when n is 4k plus 3, this one again, I mean this is even number and this is a multiple of 4. So 2 times 4 is 8. So this one is the product is a multiple of 8. So in all cases, this product is a multiple of 8. So we want to find a case when this product is a multiple of 9 on the second stage. So to be a multiple of 9, in this case, the last number cannot be a multiple of 9 because it's not a multiple of 3. So in this case, whatever the value of n is, the remainder should be always 2 when the number is divided by 3. So we don't have to think of the last number when we talk about if it's a multiple of 9. So if we see the first 3 numbers, there are 3 cases when n is itself a multiple of 9. The product will be a multiple of 9. Or when n is 9k plus 1. In such case, we can make the second number n minus 1 multiple of 9. Or the third case is when n is 9k minus 1. In such case, the n plus 1 is a multiple of 9. So in these 3 cases, we can make the product a multiple of 9. So going back to the problem, we want to find the first len least values of n, which make this product a multiple of 9. Actually, it's we want to make the product multiple of 72, but we already showed that this product is always a multiple of 8. So we only need to show this product is a multiple of 9. And if we want to find the 10 least values, so we can start from k is 1. When k is 1, the first triple is 8, 9, and 10. And when k is 2, what are the three triples when k is 2? Can you find the value of n's when k is 2? Yep. Yep. And when k is 3? Yep. And what will be the 10th value? Yeah, k is 4. When k is 4? When k is 4? 35, right? 35. We are looking at this one. Yeah. So the 10th value will be 35. So these are the 10 list values. So can you find the sum of these 10 values? Yep, add these 10 values. Yep. Great. Yep. So the sum is 197. Yep. So the answer is B. Yep. Yeah. From 23 to 25. Any problem? Yep. Okay. Yep. Let's go through it. So 23. Yeah, for this problem, let me use a calculator to show you the situation more clearly. No, 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 23. Okay, okay. Let me see. So we wanna make a pentagon. So to be a pentagon, there are 5 vertices. This. And we can make 4 segments for each vertex. So let's just start with the vertex having all the same color. So if we start from a red color from one vertex like this, we want to find the complement. Complement means we want to find the case when all triangles are made of different color. So to make the triangle having the different color, uh, this should be the blue now. Now all triangle have made of the different color. But the problem is this one. If we make this segment red, now this triangle will all have the same color. Or if we try to make this blue, now the bottom triangle is made of all the same color. So that means starting from all the same color from one vertex, we always end up with a triangle having the same color. So that's not the case we want, because we want to find the complement. So we needed to reduce the number of colors from one vertex. Let's say uh, it has uh, three red color and one blue color, and we are trying to make all triangles having different color. But once again here, this segment is still a problem. We cannot make this segment blue or red. So even this is not possible. So that means only choice remaining is from one vertex. We need to start from two and two different colors. And then now we can make this bottom segment, uh, the left one blue and right one red. And then there will be two choices for this bottom, this segment. Or you can make this either blue or red. So let's say this segment is red, and by making this red, uh, this one should be blue, and if this one is blue, this one should be red, because there are two blue segments in the bottom triangle. And finally, the last segment to make a star. Oh no no, this one should be blue, because uh, this red and there, so this should be blue. So now all the triangles are having the different colors. So this is one example of a complement. And we can do the same thing starting from the blue segment at the bottom. Yeah, so this is default. And then starting from blue instead of red here. Now this one should be red. And if this one is red, this one should be blue. And then because these two are blue, this one should be red. So we can make another complement. So there are two cases. If we start from uh, two different colors from one vertex, and because one vertex has four segments, we are choosing two segments for having one color. That means the number of choices 4C2. We are choosing two segments out of four, and each case has two cases. The bottom can be either blue or red. So can you think of a number of cases when two is selected out of four? Yep, yes, this means let's say there are four letters And how many pairs can you make out of these four letters? Oh, okay, 12, but yeah, so you can make this type of a pair, right? But in this case, because order doesn't matter, you can just divide it, 12 by 2. So, yep, so 6 times 2, yep, so the complement is we can make 12 triangles. And because there are the 10 segments in total, and each segment has the same probability. Each segment can be either blue or red. So the total case is 2 to the 10th power. And we are subtracting this complement out of the total cases. And for the probability, we are dividing this by the original number of cases. So can you find the fraction from the choices when you simplify this? Yep. Y- Yep, and then you can simplify this fraction. Uh, okay, can you find the choice? I mean, from the options. Yep, you're right. Yep, so the answer is D. I think you're right. I mean, let's see. Yep, D. Because it's divided by 4. I mean, am I right? Something. That's actually 12, right? Let's see. This is 12. So now when we divide this by 4, the fraction comes out. And number 24, uh, let me try to show you. Mm. So the first possibility is, I mean, uh, the bottom layer is made of all white cube, and the top layer is made of all blue cube. That's obviously one case. And let's say at the bottom layer, there are three blue cube, and on the top layer, there is one blue cube. And how many cases can you make in such arrangement? Uh, three, three blue at the bottom and one blue at the top. Yeah, how many cases are possible? Yeah, let's just see. How can you visualize this, right? I mean, how can so? I mean, one possibility is like this. These three are blue and one top is like this. That's one possible arrangement, right? And then we can rotate. We can rotate this blue. I mean, at the top. Yeah, four. So four cases are possible, and now the remaining cases, two blue at the bottom and two blue at the top. And how many cases are possible? Two and two. Yep. In this case, we need to be a little more careful because let me show you what I mean. Yeah. Yep. So only diagonal makes sense in this case, right? So what I wanna say is, oh, yeah, one type of a diagonal is, yeah, this type of a diagonal. One is hidden. So that's one one possible arrangement, or just, or we can also think of oh mm, this type of diagonal, two and two and two, and then the hidden one. So we can make two arrangement uh, when two and two are in the separate layer. So now, how many cases are in total? So when the four cubes are in one layer, that's one case. And for the rotation, the 1 and 3 makes 4 cases, and 2 and 2 makes these 2 cases. So the sum is, yep, yep. For the last problem, what is this? Yeah, so let's first look at the problem. This big square's side length is 1, and we want to find the area of this rectangle R. We want to find the sum of the area of R. So there are more than one type of rectangle in the place of R. That's the question. So let's go back. This 1 and 3. No. Okay, okay. So uh, we don't know the side length of the big square. We know this each side length is 1 and 3, and we are making this type of a big square. So let's say in this small right triangle, the shorter leg is A and the longer leg length is B. And because these two triangles are similar, if the hypotenuse is 3, this length will be 3 times B, and this one is 3 times A. And these two triangles are congruent because hypotenuse is 1. So we can use B for these lengths. And if we make this right triangle, this length is still A and B. And then let's say this angle is theta. So these two triangles at the upper right, these two triangles are similar, so this angle is also theta. this one is also theta, and because these bottom two triangles are yep, similar, and then this is B. These two triangles are congruent. This triangle and this triangle is congruent because it has the same hypotenuse and the angle theta. So I want to express this length in terms of theta and b. That means the length of this leg is b over tangent theta. And the length of hypotenuse is b over sine theta. So we can do the same thing in this triangle because they are congruent. And then let's look at the big square now. So because that's a square, I mean this length should be the same as this length. So if we compare this big side length, A and B is cancel. So to be the square, B should be 1B should be equal to 3 times A. So the ratio between A and B is 1 to 3. So if we look at this triangle, because this triangle is similar to this triangle, the ratio between two legs should be also 1 to 3. So if the longer leg is b over tangent theta, this shorter leg should be b over 3 times tangent theta. And then let's just see how to express these two legs. Because one side length is equal to 3 times b plus a, if we subtract these 3, the remaining length is 2b minus b over tangent theta makes this length. And for the length of another leg, 2b cancel. That's the length of another leg. And because the relationship between these two legs is tangent theta, if we multiply tangent theta for the vertical leg, that will make this a horizontal leg. And so by doing it, we can make an equation. So let's multiply tangent theta to the vertical leg. And then b is 3 times a, so we can change b to 3a. So the equation is converted to and we can cancel all a's. We can divide both the sides by a, and then let's multiply tangent theta to both the sides. Yep, so you can factor this equation. So when you factor this equation, what's the value of tangent theta? Okay. But in such case, the middle one will be 5x instead of 7, right? So instead of 2x, you can try 4x and x. You're right. Yeah. So that means yeah, the two values are the 1 and 3 over 4. So there are two possible cases. So the first case is when tangent theta is 1. When tangent theta is 1, I think this r becomes square. Am I right? When tangent theta is 1, this b and b, so one side length is square root times b. Yep. So that means the area will be square root of 2b. The area will be 2b squared because one side length is square root of 2 times b. But let me think again. Yeah. And second case is when tangent theta is 3 over 4. Now each side length is different in this rectangle. So when tangent theta is 4 over 3, 3 over 4. So this length is 5b over 3. Am I right? Because this one is 4 over 3b and this is 3 over 3b, so that's why this length is 5b over 3. this length. If tangent theta is 3 over 4, 3 over 4. So this one is 2b over 3, 4 over 3, 3, 4 over 3. Yep. Uh, so for this one, because tangent theta is 3 over 4, so 5 over if we multiply 5 over 30 here, that will make this hypotenuse 34 and 5. 34 and 5. Yep. So yep. So that makes so that's the second triangle, the rectangle is area. So we wanna find the sum of these two. And that makes finally we wanna find the value of b, and we can use this Pythagorean theorem. The a squared plus b squared is 1, and b is 38. So at first, if you make this Pythagorean theorem, what's the value of a? Yep. You're right. So a squared is 1 over 10, right? And because b is 38, so b squared is 9a squared. So b squared is 9 over 10. So, yep. I mean, so instead of b squared, now we are going to put 9 over 10. Wow. So if we simplify this one, so the sum of the rectangle area is 57 divided by 15. Yeah. And then yeah, so that's the answer. And now what's the sum of the numerator and denominator? But let me think of sorry, I was wrong. This is 52. Sorry. When it's divided by 2, 52. Yep. Yep. Yeah, 67 is the answer. Yep. Yep, 67. Yep. So I think that's enough for today. So yep, you don't have to set the deadline for your homework. Whenever you are done, just send me the file and I send you a new one. Yep. So let's meet next Tuesday. Yep. So have a great weekend. Yep. You're welcome. Bye. Bye.